students, so we will be starting the course named Environmental Engineering 1. Code is CE 505. I am Vedatri Saha, Assistant Professor from Civil Engineering Department, JNGC, Sundarnagar. So, the first unit comprises of sources of water. The sources of water is further categorized as surface source and groundwater source. We will talk in details afterwards. Focus on the bottom part of the slide. There are two textbooks mentioned here and one reference book is mentioned for referencing and for extra notes and materials. So here is a brief introduction about water. Out of total water content on our Mother Earth, 97% of the water is salty water, saline water, and only 3% is fresh water. Over the fresh water, 68% is in frozen form like glacier or iceberg form. The remaining unfrozen fresh water is found as groundwater, which we can take out and further consume. A small fraction is present above the ground is surface water, is named as surface water, and a minor amount of water like moisture content in the air we will get. Fresh water is a renewable resource. So, the distribution of the water on the earth is shown here by a bar chart. As you can see, the saline water is 97% and fresh water is 3%. Out of this 3%, frozen form is 68.7%, groundwater is 30.1%, surface water is only 0.3%, and in other form like moisture content in air is 0.9%. Further, the surface water is distributed like in rivers 2%, swamps 11%, and in lakes 87%. So majorly the sources of fresh water is categorized as surface water, groundwater, rainwater if we collect the rainwater by any method of rainwater harvesting, and frozen water. Out of these four, surface water is easily available. Groundwater we have to take out from the ground, and rainwater we have to harvest or collect. Frozen water generally we can't consume or use. So here is a flowchart of sources of water like surface sources and groundwater sources, or you can name it as surface sources. Surface sources is further divided into rivers or streams, lakes, ponds, impounding reservoirs, etc. Subsurface sources further categorized as spring, well, infiltration galleries, etc. So from all the sources we have to first collect the required amount of water, and the structure, civil engineering structure which we are needed for collection and withdrawal of the water is named as intake works. Further, after collecting with the help of intake structures, we have to treat or purify the water because raw water we cannot use. So there are several types of treatment processes like sedimentation, coagulation, filtration, disinfection, and miscellaneous treatments. After the treatment or purification of the water, we have to distribute that water by majorly three systems to the consumer by laying district water mains or branch pipe or service pipes. And after consuming that water, we generally produce wastewater. So surface water is the water in a river, lake, pond or freshwater wetland. It is naturally replenished by precipitation, or you can name it as rainfall, and naturally lost through discharge to the ocean, seas, and also by evaporation process. Here is a pictorial diagram of groundwater. We will discuss about the groundwater processes and the terms related to groundwater afterwards. So the basic uses of water are first for household activities, for domestic purposes, for industrial uses, some environmental activities, or for agriculture or irrigation, and some portion for recreational purposes also. So surface water we can get from ponds and lakes, streams and rivers, storage reservoirs, oceans, but not used for water supply purposes. And groundwater we can get from springs, infiltration wells, tube wells, maybe shallow, maybe deep. So natural sources are rainwater, river, stream, pond, sea and ocean. And man-made sources of water are dam, reservoir, tube well, hand pump, canals, etc. So in details, now we can discuss the surface water supply. Surface water supply is the most contaminated supply, mainly due to discharge of sewage, used water, which is the source of various waterborne diseases, runoff, surface runoff from the land, from roads and streets. Also, it is a source of pesticides and fertilizers, industrial discharges, which are also the source of variety of contaminants or pollutants. So surface water needs the maximum treatment for potability. For potability means for satisfactory level of drinking water. Further, we can say surface water can be classified into calm water means lentic water and running water means lotic water. There are various factors which affect the calm water quality like temperature, sunlight, turbidity, dissolved gases and various nutrients. And the factors affecting running water supplies are less than the calm water quality. Only the major factor are current and the nutrients present in the running water. Now, for groundwater, it is supposed to be the purest form of natural water. It is least contaminated and low turbidity due to natural filtration of rainwater. It may be contaminated under the ground if there is a presence of limestone deposit, septic tank, leakage from the septic tank, you can say, or underground deep well leaks. Therefore, it should be treated by disinfection. It needs only mineral removal treatment when compared to surface water. In the groundwater, majorly more dissolved minerals compared to the surface water are present, like calcium, magnesium, iron, manganese, sulfur compounds, and etc. So the bottom zone of the saturation means where the natural groundwater level is present, is marked by an impermeable layer of rocks, clay, or any other material. Water cannot soak through this layer, so water slowly flows down to downhill portion. There are two main supplies of groundwater: springs and wells. Whenever an aquifer or an underground channel beneath the ground reaches the ground surface, such as a pond or a natural water body, water starts flowing naturally, and this natural flow of water is known as spring. A well is a device man-made to draw the water from the aquifer. Aquifer means a geological formation of soil or rock or clay from where we can get a sufficient amount of water. Deeper wells is more than 100 feet, which have less turbidity, less muddiness, more solid minerals, and less bacterial count than shallow wells. Now, infiltration gallery, it is a horizontal or nearly horizontal tunnel, usually rectangular in cross section, having permeable boundaries so that groundwater can infiltrate into. So in the infiltration gallery, from the nearby areas, groundwater infiltrate to the particular tunnel, to the particular path of water. It is also used to collect groundwater near marshy land or water bodies and storage in storage tank, and can be used further for water supply. Now we will discuss some points regarding the selection of water resources, because earlier we see that there are several types of sources are present on our Mother Earth, but we have to select a particular source of water to provide a required amount, a sufficient amount of water for that particular area, or you can say town or city. So the first point is quantity available. The quantity available of water from the source must be sufficient to meet the various demands during the entire design period of the scheme. It means, suppose we have to design an intake structure or a treatment plant for 30 or 40 years. So the design period is 30 to 40 years, and for that period, for the particular area, we have to fulfill the various demands, means the various uses of water, like for household purposes, for recreational purposes, for institutional purposes, for agriculture or for irrigation, and for industry also. Next point is quality available. So the water may not be so toxic, so poisonous that the cost and the time required for the treatment to purify that quantity of water will be enormous. So the impurities present, the pollutants present should be such that those pollutants should be removed easily and economically also by normal standard treatment methods. Third point is distance from the source. The source of water should be situated as near the city or the town where we intend to distribute the water. When the distance between the source and the area or city is less, the lesser length of pipes are required and it will be economical also. General topography of the intervening area. The area or the land between the source and the city should not be quite uneven. It should not contain deep valleys and high mountains. In case of such uneven topography, undulating topography, the cost of support and the cost of carrying pipes, water pipes in valleys and constructing tunnels will be enormous. Next point is elevation of source of supply. The source of supply must be on a high contour, on a higher level, lying sufficiently higher than the city level. So by natural gravitational flow, the water will be flows down to the city. When water is available at lower elevation from the city level, pumping has to be used, which involve a huge installation and operational cost also. So in the next lecture we will discuss about reservoir.